Hey, welcome back. Tonight's homework is all about right triangles and really just setting the stage for our upcoming trigonometry units. Number one, and it looks like most of these first few problems are all about solving for a missing side and just using the Pythagorean theorem to do so. Let's go ahead and set this first one up. We got 3 squared plus 4 squared. Looks like this is going to be one of our Pythagorean triples, equals x squared. 3 squared is 9, 4 squared is 16. When we add those together, we get 25. Now, normally, algebraically, when we take the square root of both sides, we include a plus or minus, but because we're working with shapes and these geometrical objects, we're going to ignore the negative solution here. It doesn't really make sense for this side to have a side length of -5 units. Number two, this one actually is one of our special right triangles, but I'm going to save the special right triangle stuff for later. Let's go ahead and just use Pythagorean theorem here to solve for x. 7 squared is going to be 49, and 49 plus 49 is going to give us our x squared here. Move these up just to give us a little bit more space. So 49 plus 49 is going to be 90, what would that be, 98? Yeah, 98 is x squared. And then we want to take the square root of both sides here. So we get x equals the square root of 98. Now you could simplify that. The square root of 98, 98 is divisible by 49, as we just saw. So it's going to be 7 root 2. Either one of these two answers is going to be fine, but I think with the 7 root 2, you can identify it a little bit easier as one of those special right triangles. For number 3, we've got 20 and x and 29. Here we're looking for one of the missing legs. So make sure that that x squared is on being added to 20 squared. So 20 squared plus x squared equals 29 squared. 20 squared is going to be 400. And 29 squared is 841. So getting some big numbers here. 400 plus x squared equals 841. So here I want to subtract 400 from both sides. Gives me x squared equals 441. I don't think that's a perfect square. Actually, no, you know what? It is. Okay, this is actually going to be a Pythagorean triple. Okay, so x is going to be 21 here. Okay, moving right along. Number 4, another Pythagorean theorem problem. So we've got x squared plus 6 squared equals 13 squared. 13 squared is going to be 169. 6 squared is 36. So when I subtract 169 minus 36, I get 133. Now that I'm pretty confident is not a perfect square. So x squared equals 133. I don't even think that has any perfect square factors, so I think our answer here is just going to be the square root of 133. Number 5, our unknown is one of the legs again. So we've got x squared plus 12 squared equals 14 squared. 12 squared is 144. 14 squared is 196. And 196 minus 144 is going to be, let's see, that would be 52. So take the square root of both sides, we get root 52. And the square root of 52, does it have any perfect square factors? Yeah, you know what? It does, 4. It's 4 times 13, so this is going to be 2 times the square root of 13. I'm really happy with either of these two answers. It is good to know how to simplify it, but if you leave it as root 52, I'm pretty happy. Number 6, our unknown is the hypotenuse here, so make sure that that's going to be by itself in the equation. We got 16 squared plus 30 squared equals x squared. 16 squared is going to be 256. 30 squared will be 900. And then when we add those up, we get 1,156. I'm going to have to check on the factors on that guy. But that looks like kind of a nice number. I wonder if that's going to actually... Yeah, that actually is a perfect square. It's going to be 34. All right, number 7, we've got a ski lift that's forming a right triangle. It says use the Pythagorean theorem to approximate the horizontal distance traveled by a person riding a ski lift. Round your answer to the nearest whole foot. So we'll set it up just like we did the previous problems. We got x squared plus 1,170 squared equals 5,750 squared. Definitely going to need a calculator for this one. See. So yeah, this is going to be some large number here. 1,368,900. And then this will be another big number. Got 33,062,500. Okay, so we'll go ahead and subtract here. Even though the numbers are big, we're still basically doing the same thing. And finally, we'll take the square root. It says round to the nearest whole foot, so we're going to say that x is approximately 5,630 feet. All right, there's number 7. All right, number 8 through 10. Here it looks like we're working with our special right triangles. First one's a 45, 45, 90. So if this is x and x, that means that this hypotenuse is going to be x root 2. Okay, and that's going to be how we actually end up solving for x. I'm going to set up this little equation here. 16 equals x root 2. And we can divide both sides by root 2. So x is going to be 16 divided by root 2. It says give your answer in simplest radical form. So we need to make sure to rationalize the denominator. And we can do that by multiplying both sides here by root 2 over root 2. That'll give us our final answer here for x, which is going to be 16 root 2 over 2, which can be reduced. 16 divided by 2 is 8, so we get 8 root 2. Number 9 is a 30, 60, 90 triangle. So if 5 is my x, the long side is going to be x root 3. So there's really nothing for me to solve here. It's just going to be 5 square root of 3. The hypotenuse is twice the long side, so if it asks for the hypotenuse, this would be 10. Speaking of number 10, we have a 45, 45, 90 triangle here. So this is x to x root 2. So this is just going to be 8 times root 2. Number 11, another 30, 60, 90. This is x to 2x to x root 3. Maybe I'll label that just for fun here. And so if this is x to 2x, that means x is going to be half this length. So x will be 11. For number 12, we've got 30, 60, 90. This one's kind of interesting because typically the ratio here is going to be x to 2x to x root 3. So if this is x, the shorter side will be x divided by root 3. All right, because I need to multiply root 3 to get this side. And then this is twice this. So 2 root 2 is going to be twice x over root 3. Really kind of a crazy setup here. But here we're going to solve for x. So I think the first thing to do to kind of simplify things is just divide both sides by 2, and we can clear out that 2. Oh, lost my fraction here. There we go. All right, so the equation's cleaned up a little bit. The next thing we need to do is to multiply both sides by root 3, and that is going to give us our answer here. So root 2 times root 3 is going to be root 6. Number 13 is a pretty straightforward 45, 45, 90 triangle. So if this is x, this would be x root 2. So it's just going to be 9 times the square root of 2. All right, so there's number 13. Number 14 says Andre is building a structure out of playing cards. Each card is 6.3 centimeters long. He tries leaning the cards against each other so that the angle at the top is 90 degrees. We've got a diagram down here. We want to find the distance between the edges of the cards to the nearest tenth. Well, if this is a, if they're positioned like this, we know that these have got to be the same angle measures because these two sides are the same. This is going to be a 45, 45, 90 triangle here. It's going to be one of our special right triangles. So this would be, this is x to x. This would be x root 2. So x is going to be 6.3 times root 2. And it does say round to the nearest tenth, so I'm going to put this in my calculator. 6.3 times the square root of 2 is going to be about 8.9. And that's in centimeters. Okay, number 15 says find the value of the trigonometric functions. We've got a right triangle. All three sides are labeled here, so it's really just a matter of knowing what the ratios are. So if we're going to do sine A is this angle right here. Okay, that means that BC will be the opposite side, and AC will be the adjacent side. 25 is just always going to be the hypotenuse, so we don't need to worry about that too much. So sine of A, since sine is the opposite side divided by the hypotenuse, is going to be 7 over 25. Cosine A, cosine is the adjacent side divided by the hypotenuse, so that'd be 24 over 25. Tangent of A, tangent's opposite over adjacent, so that'd be 7 over 24. Doesn't really look like any of these fractions can be simplified, so just leave our answers like this. And now we'll look at those same trigonometric functions, but with respect to angle B. Angle B is up here, and what that does is effectively swaps the opposite and adjacent side. So now with angle B, the adjacent side is 7 and the opposite side is 24. So sine B, being the opposite over hypotenuse, is going to be 24 over 25. Notice that's the same value as cosine A. So when you have a triangle, sine and cosine values are opposites if you switch the angles. Cosine B is going to be adjacent over hypotenuse. That's 7 over 25. And tangent B will be the opposite over adjacent, which is 24 over 7. All right, the last section here is going to be about trying to evaluate all these trig functions for the angles on these special right triangles. This is something we did on the notes, so this is really just a rehash of that. And there's definitely a reason why we're going to be doing this kind of over and over again. So sine of 30, well, here's 30 degrees up here. Opposite over adjacent is going to be x over 2x, which reduces to 1/2. So sine of 30 is 1/2. Sine of 60, opposite over hypotenuse, would be root 3x over 2x, which would reduce to just root 3 over 2. And sine of 45 would be opposite over hypotenuse, x over x root 2. Which would reduce to 1 over root 2. We do want to rationalize this denominator, and if I multiply that by root 2 over root 2, I'm going to get root 2 over 2. That's probably the best answer for that one. All right, now cosine of 30, as we said before, should be the same thing that we get for sine of 60, but let's just make sure that is the case. Cosine of 30, 30 is up here, adjacent over hypotenuse, so that's root 3 x over 2x, and yeah, so we get the exact same answer as we did for sine 60. Similarly, we should get the same answer for cosine 60 that we got for sine 30, but just to double check, you got adjacent over hypotenuse, it's going to be x over 2x, which, yeah, is the exact same thing. For cosine 45, now with 45, 45, 90 triangle, the opposite and adjacent sides, regardless of which angle you're talking about, are the same. So I should get the same answer for cosine 45 that I got for sine of 45. Cosine's adjacent over hypotenuse, so it is this x over x root 2 ratio. So yeah, cosine 45 should be root 2 over 2. All right, these last few problems are all tangent. Tangent of 30, so looking back up here, here's 30 degrees. Tangent's opposite over adjacent would be x over root 3x. This will simplify to 1 over root 3, which if you rationalize that by multiplying by root 3 over root 3, you get root 3 over 3. Tangent of 60, going back up here, opposite over adjacent, is going to be the reciprocal of the ratio we just did. It's going to be root 3x over x. Which, when we reduce the x's, we just get root 3. And finally, our last problem for tonight, tangent of 45. Opposite over adjacent is going to be x over x, which is just 1. And that about wraps it up for tonight's homework. Thanks for watching, and y'all have a great day.